In this section, we will go through the four main limit states that we come across on a daily basis to design any structural element. And then we are going to relate between those limit states and the fatigue load and what is common between them. And finally, we're going to explain in a bit more in a detail the philosophy of the fatigue design. In our daily design, we design for the requirements of those four main limit states: strength, serviceability, durability, and sustainability. But we want to know, where does fatigue fit within those limit states? This is what we are going to know in the next slide. First limit state we design for is the strength limit states, and which is basically failure in a ductile manner with a specific performance. And it's obvious that the common thing between fatigue and strength would be that both of them do not allow for failure to happen. The second limit state we design for is the serviceability limit states, which is all about static aspects of the structure and the human comfort criteria. When we move forward in this series, we will find out that there are specific wind vibration modes that cause significant fatigue damage. From there, the common thing between fatigue and serviceability would be the vibration. The third limit state we designed for is the durability, which basically ensures that the structure has a satisfactory performance throughout its service life. And from there, it's kind of obvious that the common thing between fatigue and durability is the service life, as both of them identify a useful life for the structure. Finally is the sustainability, which kind of came new to the industry, and the sustainability measures the environmental impact of the building throughout its life cycle. And from there, as we said before, that the method of fatigue assessment shapes the life cycle of the structure, and it identifies the maintenance regime, the inspection intervals, and the useful life of the structure. From there, the common thing between fatigue and sustainability is the life cycle. As we might have noticed that the fatigue has a common thing from each limit state. So where does fatigue fit? That's what we are going to know in the next slide. We could say it's a different species altogether. You are familiar with these acronyms: ULS, Ultimate Limit State; SLS, Serviceability Limit State. Now add to your list FLS, Fatigue Limit State. It's an independent limit state by itself. But it's fair to say that each limit state has a final target. For the visibility limit state, we could say that the final target is the durability. For ultimate limit state and fatigue limit states, we can say that the final target is to not allow for the failure to happen. And from there, we sort of are going to hold a comparison between fatigue limit state and the ultimate limit state to understand that the underlying philosophy of the fatigue limit state and how the fatigue limit state handles the failure. Ultimate limit strength state versus fatigue limit state. Let's see the philosophy of the fatigue design through the comparison between the fatigue limit state and the ultimate limit state. First, let's talk about the target. We agreed upon the fact that both of them do not allow for the failure to happen. But there is a slight difference. In ultimate limit state, it prevents the failure, but in fatigue limit state, it delays the failure. Failure due to fatigue is inevitable, and it's gonna happen after the service life of the structure is over. Second thing, fatigue in the ultimate limit state is meant to be ductile failure. Unlike the fatigue limit state, failure due to fatigue is sudden failure. Second thing is the characteristics of the cyclic loading. Fatigue limit state is very sensitive to the characteristics of the cyclic loading, whether the amplitude is variable or constant, whether the mean stress is tension or compression or zero, and the length, the number of cycles of the cyclic load, the amplitude of the cyclic load. All these characteristics impacts the fatigue strength. On the other hand, the only concern for the designer is the peak stresses and the peak stresses only. The yield strength exceedance in the fatigue design code allows you to exceed the yield strength at the location of a stress concentration. Okay, as we can see, cyclic loading exceeds the yield strength limits, and this is an explosive event if you exceed the yield limit, as we can see here. And this happens only at local spot next to areas or zones of high stress concentration, like at weld toes. But in the other hand, the ultimate limit state, you never exceed the yield strength. The stress limit is the yield strength with a bit of margin as well. Finally, the material strength. The material strength in the fatigue design has nothing to do with the material grade. It is actually depends how you build the connection, whether it's welded or bolted, or you are checking plain steel member. Based on that, you get your fatigue strength irrespective the material grade. On the other hand, the the strength is defined by the material grade, which dictates the yield strength and the ultimate tensile strength. The other thing is the strength reduction factor. As we said, strength reduction factor reflects how much reliability you have in the performance of the structure. And that's defined by the method of fatigue assessment that we spoke about, whether it is safe life or damage tolerant. On the other hand, the strength reduction factor is defined by the mode of failure, whether it's compression, tension, shear, or whatever.